what are functions really? Functions are just basically two variables that are related to each other. So they're kind of linked to each other. So say x's value changes, then y's value is going to change accordingly. So it's going to be more, y is always going to be a certain amount more or less than x. Okay, so by the end of this video, you are going to see that you've actually been doing functions for years and years already in primary school and you just didn't know it. I'm also going to show you how to work with functions just practically. And then lastly, very importantly, this is the most important part of this lesson, you're going to see how you can substitute x or y into an equation to get the value of the other one out. Now, this is something that I keep on seeing grade 10s and grade 11s that come back to me that are struggling with functions. They come back to me and I have to go back all the way to grade 9 and show them this. And then they're like, oh, why did nobody ever tell me that? Okay, so now this is me telling you this. Okay, so stick around for that. Let's get going. So in primary school, you did a lot of these sums. I like to call them number machines. So you would have a rule like here in the middle, like times 2 plus 3. I'm sure you remember these. There's a number 3, that's like an input number, then you put that through the rule and then you get an output. So 3 times 2 is 6 plus 3 is 9. I hope you guys remember doing this. Okay, and you could also have an output that's slightly more difficult. You just work backwards. Say 19 over here, minus 3 is 16, divided by 2 is 8. And that's basically functions, okay? Let me show you how that is functions. So let's imagine that this area over here is your x. This box is your rule, or what we're going to call now your equation. And then this over here is your y value. Okay, so do you see we've actually got coordinate pairs here? We've got a 3 and a 9. We've got a 5 and a 13. And we've got an 8 and a 19. See? For every value of x, there's a value of y. Simple as that. It's a function. Depending on the rule, you'll get a different shape of function being drawn. So the rule I've given you here is a straight line function. So I'm just going to convert that into the formula for you. You've actually got my complete permission to forget about these machines from now on, okay? But I just want to show you how I convert this into a straight line formula. So remember, our straight line formula is y is equal to mx plus c. That means we always have something being times by x and something being added or minus. You can also have something dividing by x. So if I have to convert this rule into an equation, I can just say y, that's our output. Our output is going to be equal to x times 2, right? Because we take that input number and we times it by 2. So it's 2x. And then we add 3. Let's test if this works. Let's do an input of 5 just to check. So that's going to be y is equal to 2 times 5 plus 3. And that's going to give us 13. And that's exactly what it was over here. So we've actually figured out, I've just shown you how to take this rule into an equation. It's as simple as that. So we can also plot this, obviously. I can plot this on a Cartesian plane. So if I plot this, I can plot the 3 and the 9. I can plot the 5 and the 13. And I can plot the 8. I haven't done this on graph paper. I measured my things precisely. It's going to make a straight line like that. And it's going to go through the 3 on the y-axis. I've got my reasons how I know that. It's coming up in a later video. So the takeaway I want you to get from this whole thing that I showed you now is that these coordinate pairs are really linked to each other, okay? So you can see that for every value that I have for x, I've got a value for y, and for every value I've got for y, I've got for x. So I'm not going to find with this equation, this straight line, I am not going to find a coordinate pair that is 8, 9. I'm not going to be able to mix these two, see? Okay, so I just want you to get that, okay? I want to show you two examples of how this can work. So let's say we've got two twins. Yes, I can't draw. Let's call them twin A and twin B, okay? If I had to write, because they're born at the same time, if I had to write an equation of how their ages relate to each other, I would just say the age of twin A's age is the same as twin B's, right? So if I had to draw this as a graph, basically I'd be able to say, let's plot A here, that's the Y, let's plot B here, it's the X. So that means that when this one is 2, that one will be 2. When this one is 10, this one will be 10, whatever. Okay, we're actually going to get a really straight line going like this. Okay, makes sense? The coordinate pairs are literally going to run 2, 2, 10, 10, 20, 20, 11, 11, whatever. They're going to remain the same age. If you want to find out what the one twin's name is, so if you want to age, if you want to find out what twin B's age is, then you can just substitute it. So if I say twin B is 12, then I just substitute that in there, and then I can see A is also going to be 12. If I know twin A is minus 10 years before A was born, then B will be minus 10. That's the age. It's a really simple example, okay? Let's say we've got two siblings. Let's say you are 14 years old. So I'm going to call you Y. And then let's say your sibling, maybe your little sister, I'm going to call her X. And let's say your little sister is 10. Okay, so let's write an equation to relate your ages to each other. Your age, Y, is going to be equal to your sister's age plus 4 years. Do you agree? So she's 10 at the moment. You agree? Plus 4. That means at this point in time, you are 14 years old. Okay, so do you see we can use this equation then to figure out your ages at any stage of life. So we can say, okay, so we've already got one coordinate pair actually. We've got 10 and 14. Let's say, how old are you going to be when your sister is 23? So we substitute 23 there for her age, see, with the X. The X and the Y act like placeholders in this equation. And that's quite important to understand. So I can ask for any given age, I can ask a question. For any value of that variable, I can ask a question. I can find out the value of the other variable. So when your sister is 23, you are going to be 27. Let's ask it the other way around. Let's ask when you were 2 years old, how old was your sister? So now all we need to do is we need to solve for X. That's going to be minus 2. Okay, so we know that when she's minus 2, you're going to be 2. There's our coordinate pair from that. There's the X and there's the Y. Now, let's plot this. So minus 2, 2 is going to be over here somewhere. Then I'm just going to like fake it that we've actually drawn this axis. Way up there. Okay, so you'll have this straight line. And now you could, read your ages off the graph. If I plotted all these axes out nicely, you could actually go, I wonder when I'm this old, how old she will be. So your sister is going to be here on this axis, and you are there. Does that make sense? I hope so. So this is the line then of the graph. Y equals X plus usually label them like that. No, you can interrogate this formula. You don't even have to draw the line. You can just interrogate this formula to find your ages at any given time. Okay, and that's how functions work. So let me quickly show you. Let's just look at some random equations. Let's say we've got y is equal to 2x plus 3. I want to know, I've got a plot, I've got a coordinate pair. Remember, it's always written as x, y. So the teacher tells me, if your value for x is minus 1, what is your y value going to be? Well, it's very simple. I ask my equation. I've got an equation for this line. So she's asking, on this line, when x is minus 1, what is the value for y? So all I do is I make sure this is the same equation that's matching the line she's talking about, okay? Okay, I've got this equation. Let me ask the equation. So I just tell the equation, when my x value is minus 1, what is my y value going to be? And then I simply do the maths. Minus 2 plus 3 is 1. So then I can tell my teacher, when my x value for this equation is minus 1, my y value is going to be 1. Okay, let's do another one. Let's say your teacher tells you your y value on a certain line, y is equal to 2x plus 3, that's the equation for the line. Your y value is 6. What is your x value? So we want the x over here. So let's go. Where am I going to substitute that 6? Into the y or the x? I think the y, right? So I'm going to say line, equation of the line, the y value is 6. What's the x value going to be? And then obviously I'm minus 3 on this side, minus 3 on this side. That's for those of you not comfortable with equations yet. And then I get x is equal to, oh gosh, this is not a pretty answer. X is equal to 1.5. Okay. Not my best example in the world. Okay. There we go. So that's how these work. Okay, let's do one more example. Let's say y is equal to x divided by 2 minus 3. Let's just make it fun. Let's say we have a y value of 1 and we want to know x. So we've got y, we want x. Got y, we want x. So I substitute my y in. And I leave my y blank, x blank, because we're solving for x now. I'm going to take my 3 across to the other side in a way. I'm going to plus 3 on both sides. So I'm going to end up with 4 here. Okay, and then I'm going to times by 2 on both sides. So I'm going to end up with 8. So therefore, when y is 1, x is 8. Happiness? And I can prove to you, I can check that my answer is right like this. I can say y is equal to 8 minus 2. So I can just check it the other way around by substituting the answer I got. So that should give me 1. Yes, it does. I'm not going to make you sit and do examples with me all day long, but I do suggest that you go and do some drills on this by yourself, even if you feel like you can do it and you're okay with it. What do I mean by drills? It's like if I was trying to draw a cartoon dog, say, okay, and I'm not really good at drawing, but I can do the cartoon dog and it's kind of fun, but I really need to concentrate. If I draw that dog 10 times, I'm going to get better at it each time, but also it's going to need less concentration and brain power from me, and I'm going to be way more confident every single time I do it. So it's like that with this work, okay? I need substituting x and y into an equation to become second nature to you. You shouldn't even be thinking about doing it, really. Please click that subscribe button if you haven't subscribed already, so that I can make school easier for other people too.